Okay, so good afternoon, everyone. This is the NMRG session. So I'm Jérôme François. I'm co-chair of NMRG with Laurent Siraglia. So before we start the meeting, let me remind you the different note wells that applies to NMRG, because at IETF follow, for instance, the same rule for intellectual property rights at the IETF. So please read carefully this slide, and that in essence says that if any of your contribution or discussion that you want to share is covered by a patent or patent application, you must disclose it in a timely manner. So here you can also have the reference to the different RFC and links for more information. Also regarding audio and video recording, so we remind you that during the session is recorded. So it means that if you go to the mic to speak for people in the room, or if you're online and you also speak online, it means that you will be recorded and you consent to be recorded in that case. And then there is a privacy and code of conduct. It's recorded, and also we made this record will be made public. It will appear on YouTube, on the YouTube channel of the IETF. So also be aware of that. Important is that personal information that you provide to IETF will be handled in accordance with the privacy policies that is referred here in the slide. And also very important that as a participant or attendee, you agree to work respectfully with other participants. And please contact the Omens team if you have any questions or concerns about this. And also here you have the reference document, RFCs, that also apply to IETF. Now, also we want each time to remind you the goal of the IETF, because NMRG is a research group from the IETF. So IETF conducts research. It's not a standards development organization. IETF focuses on longer-term research issues related to the internet, while the parallel organization, the IETF, focuses on shorter-term issues of engineering and standards making. So in terms of outcome, as many of you know, but we want to remind you that we can also publish information or experiment document in RFC series as well. But the primary goal is really to promote development of research collaboration and teamwork in exploring research issues related to internet protocols, application, architecture, and technology. And also here you have as a specific RFC 7418 that gives you more information about the goals of the IETF. So here there are the different links that are related to this meeting. Of course, with all materials are on the data tracker. So that means all the presentations that will be given during the two sessions we have the IETF. There will be also notes online. Also, please feel free if you want to help to take notes. And as we said before, video recording will appear then on the YouTube channel of the IETF. So now regarding the NMRG this week, we have different meetings and sessions. We already on one signed meeting on Monday that was focused on network digital twin, in particular to discuss what could be the orientation of the research group in this area. We have two sessions during the in the IETF agenda. So one today, and we'll then show you the agenda, and another one tomorrow that will be more focused on document update status of the document and the research agenda of the group. And also, you may have seen on mailing list, we will have a joint workshop that is organized with at CZSM. That will be on Saturday at Trinity College. So you have all information on the link that is provided here. And with the objective to discuss more about the different views at each group, so ZSM and NMRG on different topics such as NDT, IBN, and AI, and then maybe also try to foresee type of collaboration or ongoing joint activities that could be done together. So for the session now, here's the agenda. So it's a mixed agenda with presentation of individual draft. So one is related to the IBM use case draft, that is I would say the collection but consolidation of the different use cases we had in the group. Then we have a presentation of a new document that is about the future research directions on energy aware security mechanism. And then we have more, let's say, technical talk. So one on the autonomic control loop with AI playing an NLP for achieving self-configuration in the slice network. And then we have a set of three technical talk on the data quality, mostly related to, I would say, network security. So I think I'm done with the introduction. So I don't know if you want to add something, Laurent. Otherwise, we can start with the first presenter, Paul.
Hello, everyone. This is Paul from Sungkyunkwan University in Korea. So basically, this draft is merging of 9 IBM-related draft. So after IETF 120, Vancouver, so the main authors listed in this first page, we work together, try to condense the content. Also, we clean up or clarify the content of use cases for IBM. Basically, this document purpose is we try to refine methodologies to build the intent-based network system, also describe our lessons from the 9 use cases draft in terms of difficulties, challenges, and research directions. So I said we merged the 9 IBM-related draft from NMRG, also OPSA WG. Okay, so the goal is we try to understand what is the potential scenarios in terms of use cases, also research direction for IBM. So this is the update. Mainly, Kehan and I, Giuseppe, we work together, try to refine this draft. So specifically, section 2.2, I reconstruct, also clarify the content of IBM according to NMRG RFC 9315 IBM concepts and definitions. So according to like intent translation, policy generation mapping, etc. Also, we also clarified each use cases, try to condense content in terms of our purpose of this document. So I try to rephrase, also add more content to show the NMRG people to understand the potential, the benefit from this document. Also, Hyun and I clarified the practice learning. Still, we needed to do more work, but I think it is a good starting point, I believe. So I mentioned the 9 draft from NMRG and the OPSA WG. So we merged together. So maybe some of the draft, maybe especially some Luis, he want to continue develop specifically, but most of drafts are merged for this draft. So next step, I believe we have now a good starting point. So we can adopt this draft as RG, and we work together, try to make speed, and we try to make the conclusion for our research community, and then maybe the IETF take advantage of this draft to make more the industry-oriented work based on our draft. So I would like ask for adoption call this meeting. Thank you for your attention. Any comment or suggestion? Thank you.
We can take comments from the room or online. Yeah, Chris, please.
Hi, Chris from Huawei. So thank you for pulling all those use cases together. I think it's a good complete illustration of relevant use cases and hangs together pretty well. I think I'd support a call to move to adoption. I think once that call is made, we can provide fine-tuning feedback, right?
Right, yeah.
And just to confirm, this would be the second informative RFC from NMRG on the general topic of IBN. Is that correct? Yeah, there was one that was kind of a concept.
The third one.
Third, okay.
We have the concepts.
Yeah.
Another one on the taxonomy/methodology,
Right. Yeah.
And then this will be the
Right.
use case.
Okay, I mean, I think that makes a pretty good set from NMRG. So.
Okay, thank you. In the meanwhile, so the IETF 121. So my student also other researchers, we work together to show the value. One of the use cases is the IoT, like self-defined vehicle management. So we show the simple translation and how to manage the moving the object like self-defined vehicle, collect the speed information. So next, the Bangkok 122, also we try to enhance the hackathon. Also, we can consider more the use cases. So we prove the concept of use cases for IBM. So that is our plan.
Okay, Paul,
Yeah.
just a few questions and comments from the chair. So you mentioned something about the draft that Luis is driving. Can you just clarify the situation on this?
Okay, I see, yeah. In the mailing list, the Luis, okay, he has two draft interconnection and transport slash intent. He's saying he agreed merging this one, but he still have some desire to develop more. So if our group agree, we can keep. But the most of consensus is we just merging is fine. So maybe the individual development case, maybe our group can discuss. Maybe Luis case you can see the second, third one. So we can discuss. But other case, I think yeah, we can merge. Yeah.
Okay, so it's not fully clear for me, sorry, but maybe in the last call that will be important to have a, let's say, a clear situation on that, because this is just from a document point of view.
Right.
If we want to proceed to adopting the document, we still have time as a research group document to bring a date to that. So depending on the progress of the draft that Luis is driving. But once we reach the IRG review, at some point we have to say, okay, these are the use cases that will be in this version. And if other use cases wants to stay out or needs more time, there needs to be a decision point. We cannot have both inside, not finished, and keep also the use cases active into the research group. This will create a bit of a mismatch from a document point of view. But we are not there yet, but I think it's important to clarify the path for that.
Okay.
Another point, maybe also important to clarify, but this can be part of the call for adoption. It's in the list of the different use cases, the draft that you're integrating. Some of the drafts were a bit inactive for some time, so it's important to check with the authors their position versus to integrate their work into this draft, even if it's not changing. And the second thing is the draft that are not, let's say, originated from NMRG, to be clear also from with the working group like Ops area, if this is okay also with the authors. Or if they want to continue their work also.
Maybe some draft case two draft is so my suggestion is we can some change the draft. So I'm wondering Laurent. So may I change submit the two draft to NMRG and then keep continue as a reference?
Yeah, of course. I
Okay,
mean,
yeah. So
there is no restriction.
yeah, in that case, I think my point of view, I think yeah, we just okay. But the thing is that the security manager automation case, that case from I2 NSF, this one is maybe a good reference, but my ambition is try to individual develop more, because this is in, extension of I2 NSF to accommodate IBM. So maybe this one is for an industry point of view, it is important. So in that case, the draft the John observability security management case. Yeah, I try to make that develop more. Yeah.
Okay, so don't want to sound a bit too technical from a document point of view, but again, it's just for, let's say, the sanity of this document.
Okay.
I think if we want to have a collective use case document, we have to separate the content of the use case that we bring to this collective document.
Okay.
Okay, that could be a description of a use case. I know you have a template. If there are a use case in another draft, even multiple drafts that continue to exist, we need to be able to separate.
Oh, separate.
We take snapshot of what the use case we describe in the collective document is at time t.
Okay, I see.
And this is what we comment upon, what the learning has been, how it maps to the architecture, etc. Because that we need to be able to keep stable at some point. Otherwise, we will never reach publication.
Okay, I see. Yeah.
If anyone wants to continue with developing use cases from an implementation point of view, from any refinement, this can continue, but it has to be a bit separated. We cannot. I mean, up to a certain point, we can keep updating the collective use case, but we have at some point to say, okay, now this is the snapshot we take. And the two things have a bit of an independent life.
Okay.
So no restriction, but we have to bring clarity how things are
I see.
in one document or another.
Okay, I see. I think the Luis, I wondering Luis in the the session, maybe he can speak his opinion, but at least my draft case. So according to your suggestion, so we separate. One group is just merge. In that case, we don't need to reference, right? We don't cite because already merged. But other the individual draft case, we can refer to informative references rather than the normative. Normative case, they should publish the RFC and then can publish, right? So otherwise they mislab. So that is my suggestion.
Okay. Yeah. So we will revisit this.
Right.
This will be part of the checks we will make when we reach the last one.
Right, yeah, exactly.
Now we are just in the call for adoption, but just to anticipate a bit on this, bring a bit of clarity what the documents will contain or not.
Okay.
Yeah, so maybe just also to confirm, because in your last slide you were asking for a call for working group, research group adoption. So, with Jerome, we agree we will proceed with that.
Okay.
The document has made enough progress.
Okay.
It has been also a collective effort, so we would like to open the call for research group adoption.
So right now, may I ask adoption call, or still waiting for?
I mean, so we are not a working group, so the process is relatively open. What we used to do with Jerome is we bring it to the mailing list so that everybody can comment. It's not just in the meeting. So we announce that we are going to proceed with the call.
Okay.
It will be an email. I expect it will be straightforward. So that's the process.
So I will ask the adoption call in mailing list, right?
You don't need to. I mean, you already conveyed.
I see. I see.
Enough. It's
maybe
it's in the minutes, and we can take it.
Okay, I see.
On the mailing list to make it official.
Okay, I see. Okay, thank you. Okay, go ahead.
Yeah, Jefferson.
This is Jefferson. I think the question is more for the chairs. As we have, if it's adopted, use cases, a merged use case draft, what is the rationale to have other documents that are also use cases separately from this document? I know it's possible to have that, but then it's difficult to to understand.
Okay, so for me it's it's a chair, but also a personal opinion where we stand today in the group. We have been having IBM use cases work and document for some time. As part of the research agenda, we wanted to bring a certain sort of conclusion to this activity. That's why we had different options to try to conclude the use cases individually, or to consider that we can bring use cases together and take the learnings of what the people have worked on the use cases together. And this will be the outcome of the research of the group has done. I think today the group agreed to go for the collective option. So that's what, so it's, you see, it's also kind of milestone in terms of where the group stands and what could be outputted as part of the group research. So that's one thing. Then a bit the technicality on having a collective use case document versus allowing to have individual use cases. For me, this is to give a bit of freedom, because the collective use case is not to say we get all the use cases and it's only there. It's just that we take a description of what has been done in the use case, and we especially focus on the learning, the mapping to the architecture. So this is really the added value of this document. I consider that individual use cases can continue to live. Maybe they need to have maybe a bit more work, maybe some implementation, some other validation. The thing is that at some point, it's a bit separated.
Yeah.
Then we can revisit, I don't know, in a year from now, if there are more use cases, more mature, we may have an update of this draft to say, okay, now we have a version 1, version 2 with more learnings, more use cases. But at some point, you see, it's just to try to bring also a sort of closure to these IBN use cases from the research group point of view. But we will not prevent individual proposals to come.
Yeah. Thank you.
Okay, thank you. Okay, so if you have more comment or suggestion, please let me know. Okay, thank you for your okay, your comments. Thank you. Okay, thank you. Cheers.
And now we have Jefferson.
Jefferson, yeah.
Good afternoon. This is Jefferson, and I'm going to present the draft Future Research Directions on Energy-Aware Security Mechanisms. So this is the agenda of the presentation. So I'm going to present a relatively long introduction. Then I will talk about the energy-aware security mechanisms, and I will finish the presentation with an outlook on the draft and the topic. So I think it's not new for anyone in the room that there is an escalation on climate emergency, and it is related to global warming. So there has been some reassessment on carbon footprint across different industries. And in this context, computer network and of course the internet are no exception to the need of reducing carbon footprint and have, for example, the use of green energy sources. And also in this context, it's possible to argue that it's easier to add sustainability considerations at the design phase of new protocols. So this can be, can be read that it's good to have this kind of conversation in on standardization bodies. So talking about the IETF and the IRTF, the green network topic has been increased. The discussion on this topic has been increased in the last I don't know, maybe 2 years or something like that. And also the green network topic has been researched for maybe something like 10 years or so. So it's not a new topic, but there's an increase on the discussion and the interest in this topic. And giving some context on that, there was an IAB workshop. It's called was called E-Impact, about development impacts of internet technology. And also it's a long documentary report on this workshop, but it's interesting reading to understand the view of the IETF, the IAB, but the IETF on this trend. After that, there were a lot of ideas that discuss some part of this green networking topic. Some talking about the I will going to talk about this later on the presentation, but I'm talking about metrics, measurements, and mechanisms and other stuff. Then we have the getting ready for energy efficient network, the green working group, which right now has some documents on requirements, terminology, metrics model. So it's kind of like a large body of discussion on how to implement a green network. And also we have the proposition of a new research group, which is the sustainability in the internet, or sustain. And people from this proposed research group, I don't know if it's proposed, not sure if this is the word, but I believe that they will propose a research group.
It's not yet. It's in the proposition phase, and if it's agreed by the IETF chair, it will become proposed research group for a year.
Okay.
And it will run as a proposed research group.
Okay.
It needs still to be decided.
Yeah, I put on gray on the presentation because I'm not sure of the situation of this research group proposed or something like that. But there were some presentations from people of this research group on the hot RFC, and also in the IETF open meeting. There was also a side meeting of this group where there was a discussion on the charter for this proposed research group. So it's a lot of discussion on that topic. And even in the NMRG, besides this draft, there are also two drafts that discuss something about green networking. The first one, which I believe it's close to become a RFC, it's the challenges and opportunities in management, which discusses, as the name says, challenges and opportunities. And also there is a draft on intents by Luis and another contributor, which discusses how to use intents to implement a green network. So also in NMRG, there is a discussion on this theme. So I don't believe it's a topic that it's in the charter right now, but it's something that has been discussed on the group. So reading out this draft and attending these presentations, it's possible to have some insights on the documents and on the people that is working on this topic. So, for example, there is a focus on improving the efficiency of networking mechanisms and to improve the carbon footprint that is made by these networks. There are some works that talk, for example, for alternate high link utilization with power saving modes and this kind of stuff. But more important especially for my research area, it's clear that it's needed some kind of measurements and metrics in order to, at the first, to understand the energy consumption and which kind of energy was being used for some kind of a mechanism and this kind of stuff. So, considering that, there are some measurements that appear in several documents. For example, power consumption, energy efficiency, carbon footprint, and the measurements and the metrics usually can present the difference of these metrics regarding different loads of the network, different modes of the network. Also, these measurements and metrics are related to networks, to equipment, to individual paths, to services, or there are lots of ways to to understand these measurements regarding parts or the parts of the network or the network as a whole, this kind of stuff. And usually there's some information in this metric is to be taken in combination. So you can, for example, you can understand the power consumption, but it's also important to understand which kind of energy is being used at some point. So there's a need to combine these metrics and measurements. So this draft, the point on this draft is that we understand that this discussion still needs to be expanded, especially considering security, network security. I believe it's some common sense that security protocols are expensive and it's possible to say that they are likely to be top consumers of energy resources. And also the usage of appropriate security mechanisms, it's important because, for example, you can avoid to use an over-provisioned mechanism or network or some kind of resource, and this can, can avoid the use of more energy. So far, the considerations on these documents that I mentioned before, they are about the attack surface of energy measurement tools. So for example, I believe that these examples are from the opportunities and challenges ID, but they talk about the to put resources to sleep in critical moments, to have some energy drain for overheating and battery loss, also to tamper with energy measurements. So the considerations are more about the security risks for energy saving mechanisms than energy saving techniques for security mechanisms. So we are proposing a different view on energy aware security mechanisms regarding this area. So we put some research challenges, and there are these research challenges are the points that we want to proceed on this document. So the first one is how to measure the energy consumption in existing network security mechanisms, and also talk about metrics considering industry-wide standardization. We know that security protocols have greater costs, and also we think that energy consumption metrics should take the functionality of these security mechanisms into account in order to avoid, for example, harming some kind of a security property of a protocol in order to save some energy. The second one is the cost-benefit analysis between security performance and energy usage. So, for example, save energy with little harm to safety and functionality, and also to, for example, to have some form of compare two or more security mechanisms to assess which one is best for a task, considering energy and carbon footprint and this kind of metric. So to finish my presentation, this is really a first version, really raw ID, but we have some questions about that. The first one, is this the right place, NMRG? Because we know that there are two more drafts on that on NMRG, but it's not a charter item, so it's not something that we we can take for granted that the working group, the research group can discuss or have the interest in to discuss. So the question is, it's okay to proceed with the ID here. We should move to another research group maybe, because there are drafts that are similar to that one on other research groups. And the second question is, if this is the right place, is there interest in the group to discuss that? Is there any person that want to contribute to the drafts and so on? So this is the questions, and I think it's pretty much my presentation. Thank you.
Thank you, Jefferson.
Questions from the audience on site or online?
Okay. So thank you, Jefferson, for the presentation. Before going back to your last questions that you have in the slide, just me ask two more, maybe more, let's say, related research questions. The first one is, if I understand well, one of your objectives is to measure the energy consumption of security mechanisms. First question is, are you aware of any maybe even preliminary studies on that, or it's completely there is no existing at all study on that?
We have some kind of a review of the literature, but it's not a systematic review at this point. But it's there's no many works that investigate that part, and we're not sure if the reason behind that. We're not sure if this, for example, something that anyone has interest in it, so it's something that it's not important, or it's something that at different times there are not, people that organize to perform some kind of a research initiative on that.
Okay, thank you. And the other question, because I mean, okay, you have security functions, you want to measure the consumption or energy consumption. I think the general methodology for measuring energy consumption to any function can be applied to to the same. So what would be maybe the rationale to a specific measurement methodology for a security function?
Yeah. I think this is this is a question that should be answered in the concept of the research. But I believe, for example, that giving an example, if you have some kind of a crypto framework or something like that, and you can choose from two or three, or I don't know, modes that are different regarding energy consumption. I'm not sure if it's the same thing to compare networking modes, like considering paths and this kind of stuff. So I'm not sure if the methodology, maybe it's the case, but right now I'm not sure about that, and I don't know that, and I don't think that there is some kind of common sense on the literature about that. So maybe but maybe you're right, and it's something that it's not really different, but I'm not sure.
Open question.
It's open question. Yeah.
And so maybe if I can just rapidly answer your last question you have here. So is this the right place? I think I don't know, or we don't know, because as you know, as you said, that there are a lot of growing stuff around green, and we don't know exactly what will be in NMRG, if there will be something, what will maybe happen somewhere. So I think let's say it's a bit foggy, but meantime, I think it's an interesting topic anyway. So I think it's good to present. So I would say that try to find the place where you have more interest. And yeah, so as I said, as also personal, I think it's very interesting. I'm not sure I can really contribute it, but surely I will look at what will be the next progress on that.
Thank you.
Okay, thanks, Jefferson. I would say I agree with what Jerome was asking and commenting. I think the IETF, IRTF, and even IAB today gives a context that you can have multiple potential areas where this could be relevant. So, and since it's an early work, I think it's totally fair that you try things and learn where you will eventually end. So don't see any issue right now with that. Also, just because you mentioned the Sustain Research Group proposal in the Green Working Group, today, I mean, there is a bit of, let's say, completely openness to say, we don't know where topics will fall. Okay, so it's also up to people like you that come with a proposal to say, we believe this is more network management centric than sustainability centric. So we would like to approach it more from the network management angle, and then, okay, maybe share to other groups. Vice versa, if you say it's more energy, maybe you go to green and you just reflect that there may be things that are a bit forward-looking and that maybe also more research than engineering of protocols. So I think it's also to the proposer to try to steer a bit, I mean, or give nuances to how they feel their work is about. I just have a question for clarification because I'm not sure I followed completely. I think in slide 9, you mentioned the second bullet point, security risk. Say security risk for energy saving mechanism, not energy saving techniques for security mechanism. So
this one, yeah.
So the focus of your work is really the first part.
No, the second part.
Okay, because that was confused by the not.
Okay, sorry. No, because I'm saying this about the current, the current literature.
Okay,
especially considering the IETF.
That's why I was confused. Okay, because then because the rest was the opposite. So I said, I must be the mistake. Yeah, maybe a comment from the research group perspective, and we repeat that. Try to come also with formulation of research questions, problem statements, because I think this will help also when you go to a research group, to a working group, to help to parse. Maybe there are things that could be more belonging to the green working group, because maybe from a metric, from a method point of view, as Jerome was commenting, maybe it's equally applicable. So yeah, maybe more success there. But if there are things that are, let's say, not covered, let's say, unexplored, then maybe it's more, we need first to research and then maybe educate a working group. So I think if you can also, with this work, try to be very clear at the beginning, spend time to formulate, these are the problems, these are the challenges we have identified. We think this is research, we think this is more engineering, or this is standards. That could also be very, even before coming with solutions, okay? It's just that clarity in this can help a lot.
No, thank you for the advice. I think that this is the first shot of the draft, so I believe that the advice from both of you will be very important, to steer the work for considering these kind of, opportunities that are in the IETF, IETF.
Right. I think we have Suleiman.
Hello, Suleiman from Cloudflare. I also had a clarification question or more of a scoping question. When you say network security, do you mean individual security protocols, or do you mean security frameworks, specific softwares, or are you also are you talking about web traffic? So I just wanted clarification on when we say we want to have energy or want to measure for security protocols, what do we mean by that?
Yeah, thank you for the question, and it's a good one. I think it's related to what Laurent said before. We're not at this point. We are just starting, so we don't have how can I say, we're not sure about how to pursue that, if we're going to protocols, frameworks, or we're not sure at this point. And maybe doing this research, we're going from having, for example, a perspective that it's more holistic about the theme. But at some point, I believe that we're going to choose some kind of a specific protocol, or some kind of measurement or framework. But at some point, I believe that we're going to more specific stuff. But at this point, we're just knowing and understanding and formulating the problem. So I understand you, and thank you for the feedback, but we're not at that point at this time.
Thanks.
Thank you, Jefferson.
Thank you. Next speaker is Angela. I think you can do.
No. Okay. Okay, good afternoon. I'm going to present my talk, An Autonomic Control Loop with AI Planning and NLP for Achieving Self-Reconfiguration in a Slice Network. This is my PhD thesis, which was finished almost 2 years ago. My name is Angela Maria Rodriguez. I studied in the University of Cauca in Colombia. My advisor, Oscar Mauricio Caicedo, and my co-advisor, Jefferson Campos Nobre. So this is the agenda. I will present you the problem, then my proposal, a very small part of the evaluation, and some conclusions. Okay, so the problem. First, let's remind what's configuring and reconfiguring network slices. Okay, first, recall that a network of slices can be seen as a service function chain, okay, where different BNF are chained through virtual links. There in the image on the right, we can see two slices, one in yellow and one in blue boxes, okay? And so what's configuring a network slice? Okay, configuring a network slice is to map each BNF of such a network slice and each virtual link of such a network slice onto the substrate network. That is, the BNF must be mapped onto the substrate nodes, physical nodes, and virtual links must be mapped onto the physical links, okay? So a configuration for a network of slices describes the instantaneous mapping of BNF and virtual links onto the substrate network. Okay, so if that's a configuration of a network slice, what it's a reconfiguration of a network slice? Okay, so reconfiguring a network slice is to migrate one or more BNF and its adjacent virtual links from the current to destination host nodes and physical links. When is necessary a reconfiguration? Okay, let's say Let's say that in this network, we have an intent defined that the usage of the physical resource, that there must be evenly usage of physical resource. So in the image of the right, you can see that node 4, physical node 4, is overloaded against physical node N3 because one has only one virtual BNF mapped and the other has 4, okay? So in this case, there's a violation of the intent that calls for the evenly usage of physical resource. So the migration, that is the reconfiguration of the network slice, will be necessary. So finally, reconfiguring the network slice is turns the network from an initial, usually undesired configuration into a goal or desired configuration. Okay, so let's suppose that we have a tenant that is owning some network slices, okay? So we have also the infrastructure provided owning the substrate network and the tenant owning the network slices, and he has service level agreement, the tenant has service level agreements with its end users. Okay, the substrate network in real world, it has the hundreds or thousands of host nodes and physical links. And in the real world, the users that subscribe such slash with the tenant may be as well hundreds or thousands. So the tenant wants to, at the side of the slice tenant is to have a control on its owned slices, okay? But we have some drawbacks. First, timely reconfigurations are needed to avoid service disruption, and the tenants want minimal dependence on the infrastructure provider. But the tenant, he or she has no prior knowledge on network configuration commands because he's usually not a professional in networking. He has no in-depth knowledge on the substrate network, and he has to respect the slash subscribed with its end user. That mainly means avoiding service disruption. In the literature, this problem is known as the tenant-side network slice reconfiguration problem. So we have a main research question. Given an undesired network configuration, how to compute reconfiguration actions on the fly to turn an SDN into a desired configuration? So the hypothesis for our work was an autonomic control loop shaped with automated planning, and NLP could compute configuration plans on the fly to turn the network from an undesired into a desired configuration. Let's understand a reconfiguration plan as a set of ordered BNF migration actions. Remind that a reconfiguration in network slices is migration of BNFs in virtual links, okay? So for this hypothesis, we have two auxiliary research questions: how to include the AP technique as a decision maker in the ACL, and how ACL decisions can be guided by high-level network management policies. So our proposal. This is our main architecture. Oh, sorry. Okay, I missed one slide, but our main architecture is based on the very well-known MAPCA loop. Okay, that closed loop that calls for monitoring, analysis, planning, and execution in a common knowledge base. Okay, so we based our architecture in such a MAPCA loop. Why? Because there are several works that affirm that the MAPCA loop performs well in realizing autonomic network management. We have several references for that. So having in mind that MAPCA loop, we have shaped such a MAPCA loop with our own proposal. First, we have added, note that we have added a module called NORA between the monitoring and analysis and the planning module. Okay, so that's our first shaping of such a control loop, the addition of the NORA module. And the other shaping is realizing the planning module of any MAPCA loop with the automated planning technique from AI. Okay, so this loop we have the tenant. The tenant expresses a network management policy in natural language. We have an intents repository, and the monitoring and analysis module is constantly observing in the managed network and querying the intents repository to check if there's any intent violation. Okay, if that happens, intent violation, it is notified to our NORA module. Okay, so NORA transforms high-level network management policies into an AP notation. Why? Because the tenant doesn't have knowledge on AI languages. So we have to bridge the interpretation gap between network management, high-level network management policies and the automated planning notations. So that's the duty of NORA. Then we have a automated planning decides which of the possible BNF migrations from a domain will take place. And the execution module enforces the reconfiguration plan on the managed network. The managed network is then turned from an undesired configuration, which is an initial state, into a desired configuration, which is a goal state in terms of the automated planning notation. Okay, so what's automated planning? Said in one phrase, AP explores how to use autonomous techniques to solve complex planning and scheduling problems. AP has been used in several domains, but no much in network reconfiguration. So that was our research. Okay, so in the figure, you see the conceptual model of automated planning. An AI planner has mainly two inputs, okay? Always two inputs. The first, the up arrow, is the domain. You have to define, generalize the real world problem defined in a description of attributes and possible actions. Any real world problem must be described like that for using an AI planner. And that's the domain, the main, one of the inputs. The other input is a particularization of a situation of that real world. So we have to define an initial state, which is undesired, and a goal state, which is desired. And that's an AP problem instance. Okay, so the AP planner will compute a plan that is a sequence of actions that will turn the environment from the initial to the goal state. Okay, that is the conceptual model. So in a mathematical way, we have to define such a real world problem as a state transition system. Okay, so the state transition system stands for, that's the domain. The domain has a set of a finite set of states, a finite set of actions, and a state transition function. Okay, we have to define that. And that's the domain. So what's an AP problem? An AP problem is the domain, an initial state, and a goal state, which is the same as the figure, but this in a mathematical way. Okay, where the initial state pertains to the set of states, and the goal state, it's a subset of the set of states. This can be also defined, this is the mathematical definition, but this can be also defined in a graphical way by an states graph. Okay, that I will show you now. Then, if this is the problem, what's the plan? So the plan is, as you see here, the plan is a list of actions that all of actions pertain to the set of actions. And those actions, the application of those actions in the real world problem will transit the environment from the state, initial state, and transit from state to state, finishing in the goal state. Okay, so this graphically is a path in the states graph from the initial state to the goal state. So this is the graphical model, a state graph. For us, we call our states graph the migration graph. So how does it work? Okay, we have, let's say we have the first configuration of the right way figure is the state one. Okay, we have a given configuration, and we see the other image is another configuration. Just moving one of the BNF locations is another configuration. Okay, so we have moved the BNF4 in yellow from node 4, physical node 4 to physical node 3. So we have another state. That is another configuration, okay? And the same, that is the graph is representing, okay? In the graph, we have in the middle, state 1, okay? And if we see the green arrow, it moves to, it's a transition of a state from state 1 to state 2. What does it mean? We are moving BNF4 that was mapped to node 4, physical node 4 in state 1, to we are migrating to node 4, node 3 in a state 2. Okay, that's a portion, but of course the migration graph is huge, as the network is huge as well. Okay, so we have defined a very exhaustive system model. This is the notations table. We have defined all a model for representing the substrate network, all regarding the state transition system, okay? We have defined the system model. Those are the notations for this is the system model for the virtualized network. This is the system model for the configuration at time step t, that is the instantaneous configuration. Just to show you a piece of the equations that we got, here we're representing the instantaneous mapping. M stands for instantaneous mapping of a function that pertains, a BNF that pertains to a service function chain. Those numbers in green in the figure represent, for the physical nodes, represent the embedding potential, which is AP in the equation. Embedding potential is the capacity that a physical element, be it a host node or a link, has. The available CPU for nodes and the available bandwidth for links. And the numbers, that is the weights of the edge in the, okay, that is, okay. Now we have to transform that, to code that in a domain, in a language, sorry, that is understood by any AP planner, automated planning. We have used the PDDL, what is the planning domain definition language. I have to tell you that this AI technique, automated planning, has its own language. It's not a common language. It's a particular language. In this case, PDDL, which is the most common. So all those system model, mathematical system model, have to be coded. You can find all my codes in the GitHub repository, and the GitHub link repository, you can find it in my paper that I will show you. And a thorough explanation of all these you can find. Okay, so this is an instance. So we have first the domain, then we have the instance problem. We have to code it as well in PDDL. And this is a reconfiguration plan, okay? Action 0 and action 1 to migrate one BNF from one node to another. Okay, action 0 and action 1, graphically seen, and what the planner shows us. Okay, the goal. The goal state has to be also coded in PDDL. But remind, the tenant has no knowledge on AI languages. So the tenant speaks in natural language. He expresses a high-level network management policy. So how did we solve it? So that's NORA, the other module, okay? So how NORA works. This is just an overview due to time limitations. I invite you, if you are interested, to read my paper, to refer to my paper for the comprehensive explanation. But okay, NORA. This is the general overview of NORA. NORA takes as an input a network management policy expressed in natural language, expressed by the tenant, and through a series of modules that we designed and developed, it transforms such a sentence in a notation, in a automated planning notation, okay? So we had to use a grammar just to show you a little piece of NORA. We had to define a grammar, and then this is the NORA operation. We have, please look at the input. It's a natural language expressed a high-level management policy, and through the process, of Nora, it becomes a goal state in the PDDL language. Maybe another language, maybe strips, for example. That depends of the last module. In the last module, we use templates. So each template depending the target notation. Okay, that was the evaluation for a trap. We called a trap to the solution based on automated planning, and we measure plan length, planning time, and that's the evaluation of NORA, the NLP-based solution. For NORA, we measure precision and processing time. Okay, conclusions. For the conclusions, I focused on giving answer to the research question. So the main. Given an undesired network configuration, how to compute reconfiguration action on the fly to turn SDN into a desired configuration. Okay, so our conclusion is AP is a feasible technique for computing network reconfigurations actions under a closed ACL. A trap, which is our AP-based solution, a trap effectively closes the MEDCA-based ACL, coping with the main autonomic network management goal. What is? That is, limit human intervention to the definition of high-level business policies. The road towards self-configurable networks by exploiting the benefits of AP under the autonomic network management paradigm is promising. Okay, how to include the AP technique as a decision making in the ACL? Okay, so the MEDCA paradigm was an adequate approach for setting up a traps architecture, realizing decision making with AP, that is, with embedded intelligence. And how ACL decisions can be guided by high-level network management policies. Okay, AP operation is guided by AP goals, into represented as conditions. With NORA, we were able to obtain AP goals from high-level network management policies expressed by the slice network tenant in natural language. Okay, those are some of the references. Time is over. Thank you.
Thank you. Question?
Hello, thank you for the talk. It was very interesting. I mean, it was a great illustration of, I mean, the kinds of inputs being provided are what some people call operational intents. So not service creating, but sort of meant to regulate aspects of use of the infrastructure. And, you know, we've kind of illustrated the whole closed loop process of handling those. That was really good. Of course, I mean, you focused on two parts. I mean, one was the sort of translation of natural language intents to something else, something that's comprehensible by particular machines. But of course, additionally, the hunt for the solution itself. I mean, you're optimizing against constraints, given targets in a very high dimensional solution space. These are tough problems to handle with ILP, et cetera. You know, the traditional techniques don't scale well. Now, you sort of talked a lot about how to frame getting into the solver, but I'm not sure I really saw what was going on in the solver. You mentioned NLP at the beginning of your talk, but I mean, and you seem to use kind of a label for the solver. So, I mean, can you sort of describe what's going on in the solver? Are you using some package that you know, you sort of defined how to get to the appropriate inputs for this? I'm just not familiar with what you may have been pointing at with how you described the solver, or was there real work in your thesis on the heart of the techniques inside the optimization solver? Thank you.
Okay. Okay, yeah, as you said, there are two main modules. There were two main modules. I have to say that they were finally not integrated. That's like a feature work. Okay, so let me go to the slide. Sorry, I missed one slide, but it's okay. Here. Yeah, we have two main modules. They were not integrated. That's a feature work. Okay, so we developed and tested NORA. In real, first we did NORA, and second we did automated planning. Okay, so NORA needs a grammar. That is the only that I show you, this grammar. Okay, all this you can find it in my GitHub. We needed besides than this grammar, we needed a long list of natural language expressed high-level management policies. What I did in such a moment was a survey with my classmates, my colleagues working in this topic. Please write any high-level management policies that you will use for a network. And I have a list. That was a first step. Then that list had to be tagged, and I trained a tool that is the RASA tool. I guess it's in the setup. With these expressions. These expressions, anytime that I found these expressions in such sentences, they must be tagged with the entity, with the corresponding entity. And then the tool was trained. Okay, and that's how we were able to do this. What I am explaining to you is the operation of the first module, the Lexer. Then we had an algorithmic approach for portioning the big sentence, portioning into different criteria. Then the converted maps such criteria in maps into the AP target notation, and the generator creates thanks to a template, creates the output that you see there. I don't know if I am clear or not.
Yeah, no, I think the impression I'm getting is that your work to date really focused on the NORA part, the using LLMs to translate between sort of natural language policies, operational policies, intents, and inputs that are usable by the network planner, rather than the network planner itself, which is fine. These are two interesting problems. I just wanted to clarify where the heart of your work to date had been. So I think you've probably answered that.
Thank you, Angela. We will move to the next presentation.
Thank you.
And please follow up on the Lenin list or during the meeting if you have more, if you want more clarification.
So next one is Omar, that will be online. It's online.
Okay.
So we'll give you the control of the slide, Omar.
Yeah. Can you hear me?
Yes, perfect.
Okay. Sorry. Okay. Can I share my screen, or are you going to?
No, you need to. We share the slide, and normally you have the control.
Okay.
You show the control button.
So, I cannot see the control button. Oh, okay. And where I can find the control button actually. Okay, now I can see the control button. Okay. Okay, thanks. So, hi everyone. Can you hear me? Okay, can you see me? Okay. So my name is Omar Ansar. I'm a third year PhD student, and I work with Jérôme and Isabelle Christman. And I'm going to present to you the last contribution of my PhD, which is about the evaluation and the improvement of the tested quality for machine learning and deep learning based intrusion detection systems. Okay, so I'm going to start with an introduction in order to ensure that we are at the same level of technical knowledge about machine learning and deep learning, at least what we need for this presentation. So machine learning and deep learning based ADS is a classification task where a machine learning or deep learning model is going to try to classify and to distinguish between normal and malicious traffic, network traffic. So the traffic can be binary traffic, like pickup traffic based on packet or flow based traffic. And the classification can be a binary classification in which we try only to distinguish between normal and malicious traffic, or a multi-class classification task in which we try to be precise on which type of attack or which type of legitimate traffic we are trying to classify. So on the right we have a figure in which I illustrated like how we can use machine learning based EDS. So the machine learning based EDS in this case, it's a random forest, is placed between a company line and the internet, and we have here a bidirectional like flow, and the IDS is going to try to classify the traffic and try to raise an alert if if the traffic is malicious or if there is an attack. So there is many algorithms, many machine learning algorithms, and many deep learning models. So we have random forests, super vector machine, and decision tree. And for deep learning, we can use like deep neural network or even CNN. And like the typical workflow while training and testing this kind of models is as follow. So in this case, I choose it to the conventional one, in which we split the data set into a train, a validation, and test set. But we can also use cross validation, which is used when we don't have enough data. But in my case, we are going to use in this presentation. We are going to use this strategy. So you have your training, you have your validation, and you use both in order to train and try to configure your model. So by configuring, I mean like setting the hyperparameters. And so you do this in an iterative way in order to retrieve the optimal model in the step 2. And when you retrieve the optimal model, you use the model on the test set in order to retrieve the IDS performance. And this IDS performance, this value, is going to emulate the real behavior of the model in a real world situation. So it should be like this. But and during the training, we can face some issue, and this thanks to this workflow, we can leverage, and we can know which issue we have. And one of this issue is like overfitting, when the model is too specific to the training data. And so in this case, the model memorize the data and don't generalize, doesn't learn pattern. So that's it for the technical material. So we have this workflow. When we train the model with the training validation, we test it on the test set, we check the performance, and we check if we have some issue like training, like overfitting or maybe underfitting. Now we can go to our problem, to why we are in this why I switched. Actually, we wanted to contribute on the dataset quality. So in the prior work, we focused on the hyperparameter tuning and automatization of IDS implementation, and we used like IDS 2017 to the sets, two well-known data sets, which are IDS 2017 and IDS 2018. Sorry. And our work was about hyperparameter optimization and the seeding of the hyperparameter. And during some preliminary experiments, we tried like to train and validate and test our model using only the hyperparameters, the default hyperparameters provided by scikit-learn, which is a well-known library for machine learning. And the default hyperparameters provided by scikit-learn are like I just I'm just presenting here some of the hyperparameters. But typically, these hyperparameters, like the max depth, which is set as known, which is the limited depth of the tree. Typically, the intuition of this hyperparameter is that they overfit on the data. So having a max depth at known, having a mean split at 2, and a mean sample leaf at 1, we expect that the model overfit on the data, and so it should perform poorly on the test data. And what we observed is it wasn't the case. So on the graph on the right, you can see as in the x-axis the max depth value, which are increasing, and the F score, which is a metric used to check the performance of the model. And the more the trees in the random forest grow, the more the model learns, which is good. But at a certain point, we expect that the model on the test set start to perform poorly because the max depth is too big, and it should learn noise at a certain point. It should start learn some noise on the training set. So we are supposed to see that the test set plot, the test set growth, the test set curve, sorry, start to decrease, which is not the case in our experiments. So we faced some unexpected result, and despite the overfitting of the model on the data, the model, we can see that the model achieved near 100% detection on the test data. So which raise a question about like the quality of the data set, and is the data set potentially the problem? Because we only not only did the one split with multiple split and tried multiple configuration, and we always have these results. So what what we what we did is in the literature we found some measures about the complexity of a classification problem. So we found this paper that proposed some some measures, which are feature-based measures, linearity-based measures, and so on, that quantify the complexity of a dataset and quantify how much complex is the dataset for a classification problem. So on your right, for this presentation, I'm only focusing on the feature-based measures, but in our experiments, we did all the measures, and we get the same conclusion. We got the same conclusion. So for the feature-based measures, we have 4 measures, and I'm just here in this figure, in these 2 figures, I'm just trying to explain the first the two of them, the F1 and the F2. So the F1 is about finding the minimum number of features that can separate the data, that can separate the data set based on their class. So in this example, we have two features, and we can see that this feature number 1 can separate the data set into 2 classes. So this data set is considered as like with low complexity. And we have the F2, for example, which try to look for overlapping region. So this is an overlapping region because in the dataset, this is a region where we can find both the first class and the second class. So this dataset is a 2-class dataset. And the more we have overlapping region, the more the dataset is complex. And we have the F3 and F4 here also. I'm going to explain them in details like this. But and so what we did is like we use the library provided by the author of this paper, and we calculate the measures. And as you can see in this table, which are the result of IDS. IDS is just so what I did is like I merged IDS 2017, IDS 2018 into one dataset. I call it IDS. And we also calculate the measures for CIFAR-10. CIFAR-10 is a well-known benchmark for image classification, which is used in the deep learning community. So as you can see, IDS is like very close to 0 for the 4 measures, and CIFAR is very close to 1. So this series indicates that EDS may lack of variability and complexity, and this is what explain the previous result, this one, in which like the test set, in which the model on the test set still perform as good as in on the training, because there is no variability in the data. So even if the data, even if the model learn noise and match the data at 100%, it still perform well on the test set, because there is no difference between the test set and the train set. There is no variability between them. So this observation raises some questions, research questions, which are as follows. So these what we are trying to answer in my last contribution of my PhD. So the first question is about evaluating IDS performance. So are we effectively assessing model performance using the IDS dataset or using any other like IDS benchmark dataset? So is it like emulating the real world situation for IDS? And the second question is it possible to quantify or to measure the quality of a test set? If we have a test set, we can use it to actually quantify the performance of the model on the test set. But can we have a metric, or can we have like a way, sorry, to quantify how efficient was the testing, and how efficient was the test set to stress the IDS and to stress the IDS and to actually have confidence or confidence interval about the real performance of the IDS. And the last question is, okay, let's say we quantify the set, we have a measure of the set quality. If it's bad, can we improve it? What kind of strategies can help to improve the test set to better capture the model performance? So, okay.
Omar, just for the sake of time, please maybe come to the main point of your remaining slide
Okay.
conclusions. Thank you.
Okay, sorry. So the idea here is like to try to apply some test set coverage state of the art. So we have the neural coverage, we have surprise adequacy, and we have the testing. The main difference between applying test set coverage and applying data set augmentation is that the data set augmentation is applied on training, and we are trying to apply it on the test set. And so I'm going to go through this state of the art. I'm going to try to like present our solution. So our solution is trying to address the gaps of the state of the art. So we are going to try to be model independent. We are trying to propose a new metric to quantify the data set quality, and to guide the generation of test set using the metric that we propose. So the idea is to use contrastive learning in order to separate the data set by class. After that, the idea, we encode also the test set, and we quantify its quality using the proximity score, scarcity score, and the diversity score, which are based on the proximity of the test set on the target cluster, and the scarcity, which is a distribution of the test set between the cluster, and the diversity is like how diverse are the test set between them. And at the end, the idea is to apply reinforcement learning in order to guide the generation. So here I have some preliminary results where we use TC to generate like SSH traffic in a random way. But the idea is try to guide the generation and to try to have this black point here close to the target classes of the binary traffic. And so this is for my presentation. This is the conclusion. So as I said, in our community we lack of good data set compared to the other community, compared to the image and NLP and other community that have communities that have good benchmark. And for a long-term vision, like the idea is like to try not only to enhance the test set, but maybe trying to provide good benchmark for our community. And that's it. If you have questions. Sorry, it was fast.
I'd like to suggest we take questions at the end of the three presentation, because probably we not have the time to go one by one. Please stay online and let's go through the presentation, try to catch up on time, and hopefully have a bit of time at the end for questions.
Okay.
Thank you.
Thanks.
So next presenter is Jose. So we'll share the slide and we'll give you control.
Cool. Do we have a pointer here that I can use?
Pointer?
Yeah.
No, I don't think it's visible.
Okay. I'll do my best. Can you see the slides and can you hear me properly?
Yeah. Everything's good.
Okay, cool. Well, thanks for the invitation. It's very exciting for me to present this this proof of concept that we have done with in order to assess the effect of data quality on model performance in machine learning. So let me start with the analogy of the closed loop that we are making in the context of autonomic networks. So the whole idea, we take this idea from the process industry, where we have thousands of these closed loops, but the goal is to control a single variable, say a temperature, and around a set point that is human defined. And we inherit this idea to, let's say, control for this some intent, some part of the network configuration, or some service that we want to provide. And of course, the idea is to minimize the human interaction. So this analogy makes a lot of sense, but at the same time, it doesn't, because the network is much more complicated than a single variable in the process industry. So we rely basically on machine learning in order to provide all the complexity for controlling this kind of setup. Now, I will focus on the interaction between data quality and performance of the machine learning model that is going to be trained with this data. And this is highlighted in my slide. So basically, this is the feedback loop between the telemetry system and the machine learning model. So say that we want this system to work autonomously. That means that if the traffic changes or something changes in our service, that means that maybe we need to modify a little bit how we collect the data in order to maximize the quality of the model. Right. A little more detail on this part of the loop. We will be interested to understand if we can automatically assess how the data quality is affecting the model performance. And if we could do that, then we can actually optimize how the data is collected in order to improve our model by training the model with different data. For that, we need to assess data quality, but data quality is actually a very complicated thing. It's multifaceted, and that means that most of us understand data quality in a different way. So for my case study, I would like to provide a very specific definition of what we understand by data quality. If we define data quality from the machine learning perspective, let's say that we can define data quality as that data that optimize the performance of my model. So the data that will be optimal will be the one that makes my model to do the task that is trained for in the optimal way. But then again, we need to define model performance, and that depends on the task. Before, we have been hearing about optimization. There is also classification. There is also prediction or anomaly detection. These are completely different tasks, and the performance is measured in a very different way. So again, for our case study, we need to define what we understand by model performance, or what is the task that we are going to achieve through the machine learning model. And we decided to work on the identification of traffic anomalies. So basically anomaly detection. And for that, we are using one benchmark that is called the UGR16. So at the end of the day, I want to find how can I modify the quality, or what is the impact of the quality of my data in the detection of the anomalies in the UGR16. Let me give you a little more detail about this data set. So UGR16 is a real data set collecting from a real ISP. It's net flow data. flow level traffic collected for 4 months, and is divided into 2 data sets: a training data set that we use to train the anomaly detectors, and a test data set. The training data set is completely composed of real traffic, anonymized, of course, and the test data set also includes, along with the real traffic, includes some attacks that we induce it. They are real attacks and they generate real traffic, but they were induced by us, meaning that we can identify when those attacks took place. And with this, we have what we call the ground truth. So we have the labeling of the real attacks when they are taking place. So with this, we can assess the performance of an anomaly detector by seeing how accurate we can detect those attacks. Now, this is only a perceived performance, in the sense that, we know when we perform the attacks, but there is also some other anomalies that are affecting the real traffic, meaning that our measurement of the performance of the model is not 100% accurate, if you understand what I mean. So there is always uncertainty associated to the way that we measure performance. And measuring performance is necessary in any environment that we use machine learning. So this uncertainty is going to be always there, and we need to recognize that. Right, so let me restate my goal. I want to understand the challenges for autonomic optimization of data quality. So I want to optimize the data quality in my autonomic loop. And I'm gonna do, this is just a case study on a benchmark for anomaly detection, UER16, in which I will measure the data quality as that optimize the model performance in terms of detection. Hopefully this is more or less understood. Okay, so when we started with this experiment, we realized that there is much more to look into in the machine learning pipeline. There are many choices that we need to make when we want to use machine learning in an autonomic loop. From where we place the sensors to how we decide which features we are going to use in the machine learning, how we train the machine learning itself, which method for machine learning of the learning we are using, how do we validate, and finally, how we interpret the results, which is a very important topic, but I don't have time today to talk very much about it. And if you look into the literature on research, which is the literature I'm most used into, you will realize that most people is mainly concerned with the things that I have highlighted in green color. So basically, only a few parts of the pipeline. But in reality, you really need to look into everything. So we wanted to see to which extent other parts of this pipeline were going to affect the quality of the final model. Also, we were interested not only on interpreting the result in terms of accuracy, which is what is most often done in the research literature. So basically, we always look at areas under the curve or accuracy performance and similar stuff. But we also wanted to understand why our machine learning models were providing a certain output. So we call that interpretation in the feature space. And hopefully I will explain this later. So let me go back, sorry. And in order to understand the impact of all these stages into the final performance, we developed 4 variants of the UER16, that they are minor modifications of the same data set, but they vary in some minor decision that we take. So let me go to the results. If we compare version 1 versus version 2, the main difference is data cleaning. Version 1 was the original data set. Version 2 is a clean version of the data set in which we have detected one real anomaly that was taking place in the training data, and we have extracted it outside the training. So if we compare both data sets, so with both data sets, we train a machine learning model, and we see the accuracy of this machine learning model. And we did this with 2 different variants of machine learning. One that is completely linear, a very simple model that I can interpret, and a very non-linear version that is very difficult to interpret, but is expected to be more proficient. Now, I don't have much time to explain, but most of you will be probably familiar with raw curves and accuracy detection and the area under the curve. So basically, we measure the performance in terms of the area under the curve, which is an index, performance index, that goes from 0.5, which is very bad, to 1, which is very good. So basically, this is the span that we have in this performance measure. And what we found is that after data cleaning, we could improve the area under the curve by 0.2, which is a massive change. But we found almost a negligible difference in terms of the machine learning method. So a main conclusion of this result is maybe we shouldn't be so much concerned, especially in the literature, by searching new machine learning models to improve our capabilities. And maybe we should be looking somewhere else, because actually the impact in a real case doesn't have to be the data, but it could well be the data more than the machine learning that we use. Now we wanted to take a look closer into this, why this was happening. And we found that the main problem was in the detection of one of the attacks, which is a Neris botnet attack. So we wanted to concentrate on this problem. And we look into the feature space. Because I have a very simple linear machine learning model, I can actually take a look at the pattern of detection for this type of attack. And at the left, UGR16 version 1, you have the pattern of detection with the whole training data set. At the right, you have the other one. And you can see that the pattern completely changes. And the reason why they change so much is of the training data that I'm using. You can see it up there. That for the UGR16 version 1, I'm including the whole training data, and for version 2, only the blue part. Now, what I can see in the red part is an anomaly into the training data. And what I'm doing with this anomaly is telling the model that this type of behavior, that is Neris botnet activity, or very much connected to the Neris botnet, what I'm telling the anomaly detector is that this is actually normal behavior. And the anomaly detector gets tricked. So it doesn't really matter what technique you use. It's actually very important the data you use to train it. Well, since I don't have much time, I'm going to move towards the last example. Before I was talking about the quality of the training data, let me focus on the quality of the test data. And in the test data, I have a labeling. And this labeling, which was my ground truth, as I explained before, is actually the labeling that is used to compute my raw curves. And this creates my perception of quality. But there is always mismatches. So this labeling is not going to be perfect. For instance, what I'm showing here in the real case is that there are some anomalies that are labeled as normal anomalies. But when we analyze it in the feature space, because we have this linear model and we can interpret it, we found that they were real anomalies. So again, there is a lot of uncertainty associated to this type of problems. And most often, this is not correctly handled in the literature. So takeaway messages. The machine learning performance depends on all pipeline steps. So we shouldn't be only looking at the type of technology that we use in machine learning. Data quality is very important from all the perspectives. I also suggest that we have a preference on machine learning models that we can interpret, because we need a good understanding of how it's working. And only using a labeling is very tricky. So if we can interpret the model and we can see where the labeling may be incorrect, is much more useful. And we can do that with interpretable models. And finally, if I have to suggest some directions that could be interesting in this research group, I think we need to look at the whole pipeline and understand how we can automate it and how we can actually propose reliable solutions for introducing machine learning in this type of feedback loops. Here you have some materials, related materials, in case you're interested. And with this, thank you for your attention.
Thank you very much for the presentation, Jose, and for the takeaway. So as as we suggested before, we take all the questions at the end of the free talk. So, but thank you very much. And so the next speaker is Gregory. And so we'll share the slide and we'll give you the control, Gregory.
Hello, can you hear me? Yes.
Yes.
Okay. Hello, everyone. So I'll try to make it quick because I think that both Omar and Jose have actually well introduced the problem. So here I'm going to speak about an ongoing initiative we have in one of our national projects in France, where we try to evaluate the quality of intrusion detection systems. So, well, a bit about myself, but just to say that I don't know if there's a pointer, but I'm in charge of the work package on evaluation in this project, which is called Supervise, and in which both François and Omar are also involved. Oh, yeah. So I'm going to skip this intrusion detection part because it was introduced by Omar. And just to stress on the fact that intrusion detection as a function, as a security function, is analogous to classification tasks. So, for example, in misuse detection, where we look for mostly attack signatures, we can actually try to encode these signatures as patterns over the features. And the model itself, as it is for signature-based intrusion detection, is actually limited to the known attack classes that are present in the training set. And finally, well, it's costly in terms of retraining. I mean, you always have to include new signatures, so you always have to include new attack samples in order to retrain your misuse detector. For anomaly detection, again, when we are trying to point out possible deviations from normal behavior, mainly, we can say that it's analogous to binary classification, in which, for example, the classification task is actually trained on only one class of data, normally the Benin one. And then at inference time, the model needs to compute a distance from this Benin data to see whether a new sample of traffic, for example, is far from what is considered Benin, and therefore possibly suspicious. But of course, it's just an anomaly, so it does not indicate which kind of attack it could be. And then many people have actually dismissed that, believes that anomaly detection has been actually going on with machine learning, but you can, as I've shown earlier, use machine learning to do also misuse detection. So how to evaluate a machine learning based in IDS? So Omar also introduced that. So I'm going to skip this part just because afterwards, there's the classification measures that we can take. So we measure the true positive, which are for example, for us, what is positive is a suspicious packet or traffic. And if it's predicted positive, so then it's true positive. But obviously, if it's not, then we are in presence of false positives, which is one of the main issue in automating intrusion detection. That is, we do not want to raise too many false positives because it will then falsely give the impression of security, and also it will increase the work of any security operators that have to address these alerts. So the classification metrics also were introduced by Omar, and so Jose didn't have to introduce them again. But if we want to look at how they were used then in earlier work in the field of machine learning-based intrusion detection systems, you can see that in a survey, not so recent, but I will discuss more recent work afterwards. In 2015, Milenkowski actually said that most works that he encountered in his literature survey were actually using only accuracy and for different purposes. So as Omar pointed out, you need to find out like which is the purpose of your classification tasks. Here, for example, if you want to work on whether you're good at detecting attacks, so most of the time they would be computing accuracy in the presence of both legitimate and malicious malicious traffic. But sometimes they were only interested in whether they were able to detect this or that attack. And so it's like, well, if I have like a lot of signatures, I'm able to detect all attacks that are in my test set that corresponds to these signatures. So they would use only malicious workloads for that. So then they came up with this idea of, oh, it's not written here, but measurement methodology, where if you want to evaluate your intrusion detection system, you need to define what is the purpose of your detection system, what is the workload that you're going to use, and what are the specific metrics, because these metrics themselves are not sufficient. Usually, I mean, accuracy by itself will actually abstract many of the errors. So you need actually to rely on precision and recall. And so where actually many of the IDS proposals that we have reviewed from 2015 to 2022, 23. But sometimes when, for example, data set is imbalanced, so they fail to use an appropriate per class accuracy or precision measure. Also, as for data sets, so there are a few of them that are really used, although there may be hundreds of them existing for intrusion detection evaluation. But some are really old. We all know about KDD 99, and some of them actually suffer from what is called shortcut learning. That is, you have like a few teams in the world that have produced many data sets, and so they all derive from one another, and they have this problem that when they try to generate them, they usually suffer from shortcut learning. Shortcut learning is where you can take like a few, let it a single feature to completely, mostly or completely classify a data set. So this is really one of the problem, I guess, that Omar also have seen when using the data set, that he's able to easily classify the data set. So to avoid that, usually you have to, for example, let go of the identifiers of the flow and specifically the destination port. And of course, there are many labeling errors, as Jose has pointed out. So for example, CICIDS 2017, 2018, as were used by Omar, I hope he used the corrected data sets, are now, a no-go, okay? So what usually they did is that they try to provide some way of comparing their work. Okay, so that's what evaluation also is good for when we are disseminating academic research, is that we want to show that we outperform other intrusion detection systems. But sometimes they fail at doing it because the tasks, for example, were different. I'm doing supervised learning, you're doing unsupervised. We're not using obviously the same splits at all. That is, we say we're using the same data set, but I'm going to take like several runs of my intrusion detection system against the data set, and maybe I will only focus on the one that gave me the best result. So it's not really ethical, but I guess it has been done a lot in previous research and still being done today. But then also, even though I'm trying to randomize this a lot and running this many times to get some statistical significance, maybe it's best also that we use the same splits just to be sure that we accurately can compare ourselves. And finally, there's a lot of disregard about how data sets are actually generated and how they are composed. That is, sometimes behaviors may be periodic or may actually appear once in a while. And so if you take different temporal splits of your data sets, so you may have like different distributions over the features. That is, actually they cover different subspaces of your whole traffic domain. And this is really important to take into account when doing evaluation. And this is something that was really overlooked also in previous work. Okay, so I spoke about the data sets, but what are the kind of data sets that we're using? So maybe for you, it's quite understood. Most of them are like flow-based, but we can also find packet-based. And many of them obviously rely on the NetFlow format that I think you know very well in this community. So I'm not going to spend too much time on that point. One thing also that Jose also mentioned is about the representation of the data. And it's also something that is difficult when you want to compare your work. Obviously, I mean, you can say my feature set is better because I can catch like more patterns, okay? But when you want to do comparison, you may also want, if you want to compare the model itself, or a specific set of parameters, try to do that. Maybe feature sets are close, and that is difficult if you want, for example, to show that your I mean, it's not difficult. It's interesting if you want to show that your model can generalize, because as you can see here, many of the data sets that are actually being used in the community do not have like overlapping feature sets, and so that's interesting for on that point. But what if, as we said before, all these data sets are not of good quality? So we're not still answering the question, even for generalizability. So this is because when the cybersecurity community started working with machine learning, they disregard a lot of common pitfalls associated with the machine learning pipeline, as Jose pointed out. I'm not going to go over all of them because Jose already introduced them, but obviously you have like sampling bias, you have like problem of labeling, you have the problem, as I said, pointed out by Lawrence Dug, of this shortcut learning, where you can do spurious correlation. That is, for example, associating some behaviors to some destination port, while it's because only of the generating team that only said, oh, I'm going to generate legitimate traffic only from this computer to this computer on this given port. So then there's a really lack of variability and diversity in the data then. And obviously, there are many other problems that were actually discovered by Daniel Arp and his team. And obviously, they are inappropriate baselines, as I pointed out. And one problem I'm not going to answer is, yeah, we're doing lab-only evaluation. That is, we're using machine learning classifiers with features-based data sets, and we are computing the metrics here, classification metrics. How can we escape from this lab-only settings? That's also a good question. Are we able to do that when we are only considering the data itself? Okay, so I'm going to skip this one. Concept drift is just the fact that, as I said, we need to evaluate, obviously, with data that is diverse in space and time. And a few takeaways is that we do not have yet a standardized approach. Our predecessor said so in a 2023 paper, and this is what we are actually studying with Jérôme. And yeah, problem of quality, obviously, problem of baselines. And so a lot of things can be done about how we can vary the data. So that's why we're proposing some kind of framework with a student, where for each of the properties we want to evaluate in terms of intrusion detection, there's, as you can see in the center, a dataset module that is interested in constructing a dataset. Okay, not only augmenting it, but from a given data set, we may be able to precisely select the data that is going to be challenging, you know, for evaluating our data, our intrusion detection system. And so the idea is that we want to prove formally the link, but I think that's also being hinted by Jose, between data quality and model performance. So some of the questions for you to look at. Some of the answers were partially given by Omar and Jose during their previous presentation. So I'm happy to discuss these points with you all and with them, obviously. Thank you for your attention.
Thank you, Gregory. And so now it's time for question for all the last three speakers. So it can be a specific question or a global question to all of three.
Yeah, we have Renzo.
Thank you, Renzo Navas. Yeah, it was my question was for Omar, but it's in the end it's quite related to all. But thank you, Omar. We discussed this a little bit on the chat list. Now I think it's more clear. But maybe I will ask again, and you, Omar, can answer publicly. If I understood correctly, because at the end you went a little fast on your slides, but you were trying to enhance. Your complaint was this: your data was not good enough because it was low variance, too easy to detect, no many samples on the boundaries, etc. So I thought I understood you apply some method to enhance the quality of your data. If I understand correctly, this method is synthetic because you do it a posteriori with some, I guess you assume some things about what you will expect this data to have, and you apply this. That was my understanding. So my question was, why makes you think this can help? Because maybe inherently the phenomenon you are trying to study, it has this quality. Maybe it has low variance and the levels are separated. What makes you believe this, adding this, I call it noise, but adding this variance improves everything you want to do? And okay, I'll let you answer.
You can answer. You can answer, and I can guess if you understand correctly what I said in the chat. If you want.
So you answer me. It's not synthetic data. This what
Yeah.
you do is not synthetic data. We have
Yeah.
some way forms to access to generate real data on our setting or a similar setting. So you generate real data, and then you inject this real data on your already existing data to add more, to enhance your data set. But if I understood correctly, you add real data from
So
okay.
this is the part I didn't explain in my presentation, where adding noise or adding like noise, like you said, is part of the augmentation method, but it's part of the augmentation method that is applied on the training set. So if you have a training set and validation set, and you have poor performance on the test set, you apply that augmentation by adding variance, by adding some noise, Gaussian noise on the training set, and you use the new training set augmented with your model to try to make the model learn more pattern and generalize better. And then with this new model, you test it on the same test set, but you don't modify the test set with the current data augmentation method that generates synthetic and noise, because you cannot test on a synthetic test set. The test set has to be consistent. It has to be it has to reflect the real world. So when this way, the current method, that statistic handcrafted or a model-based method like GAN and the diffusion model, are not applicable on the test set, because you cannot be 100% sure that this method will generate realistic data.
Okay. Maybe I don't. So yours this change you put on the test set, but you don't modify the model, right? Only you try your model with a net tested to see if it still performs correctly. Okay.
Yeah.
But maybe, so maybe I have another question. This is a general for everybody. So, but maybe if the data was not good enough from the beginning, or model is not good enough because it didn't have a good. I think that's what we're discussing here, right? We need more quality data that represents the real phenomenon. And I think, as you say, some data models, some data sets we got in the literature are not good enough because they are too simple. I don't know.
Yeah,
but
okay. Guys, I'm really sorry. It's a very interesting discussion, but we have still two people in line, 1 minute to go. So let's try maybe to just hear the question from Yang Fei and maybe Suleiman, or take it offline if we don't have time. Thank you.
Just Renzo, if you want, we can discuss, because I'm working with Omar.
Thanks for your all work. But as large language model is emerging, such as Llama 3, so my question is that whether it is possible for your specific promote to train such a model with large language model. As a new man in this area, of course, I haven't not tried in the such a model. That's an interesting area, but I don't see many works about that. So I also don't know whether it is suitable in this research group. That's an advice. Thanks.
Okay, Young Fei, your question was directed to one of the speaker in particular or more to the topic for the research group? Just to know if you were asking one presenter in particular.
Yes, just for large language model. Is it suitable in this research group?
Okay, that's a bit of an open question. Maybe we can take it after the meeting or offline. But do you have questions for the speakers or
No?
Okay.
That's an advice. Thanks.
Okay, thanks. So maybe let's see. Let's use your question in offline. You don't have time to answer it right now. Thank you.
Okay, thanks.
Yeah, Suleiman from Cloudflare. I'll quickly convert my question to a comment because of time. But just wanted to highlight that sometimes the way that we represent the data in some of features is also important. So it's also good to see like which features are standing out. So sometimes like, especially in networking data, there's specific features like port numbers or IPs that become more highlighted and that biases the data. And so if another technique is to just drop specific features when you're training models, networking models, and that also allows us to have more diversity on your testing results and evaluation phase. And one other thing I just want to highlight is like when we're talking about IDS ready systems and machine learning systems, it's also important to look at other metrics like performance of the model itself, because sometimes the ID systems need to operate in line rate on the hot path. So we talk a lot about accuracy. So it's also important to look at how well they're performing and if they are actually applicable. And it seems to me from all three presentations that the community lacks a very good data set for IDS. A lot of lab-based evaluation will continue to have this since we lack data in the wild. So if the industry can find a good way to share proprietary data in some form, I think that will help in that manner. So more for comments than a question. Thanks.
Okay, appreciate it. Thank you. I'd like to thank the remote presenter, Omar, Gregory, Jose. Thank you for being there and also adjusting the time of your talk and addressing the questions. Thanks for your input. I think the topic was very interesting and I'd like to see a follow-up on that. A bit sorry for not being able to have as many questions and follow-up interaction live. We had some buffers, but obviously it was a bit hidden. But thanks for all the presenters and the good topic. We will try to, let's say, follow up on the mailing list, and we have also the session on Friday. I think for the question from Yang Fei, this is something you can bring on Friday because we have a bigger question on, let's say, AI network management architecture and agent kind of aspect that maybe your question can frame into that. But again, thanks to all and see you around.
Thank you.
Thank you very much.